Hello and welcome to my Pre-Algebra review series. This video covers Chapter 8, Section 3, entitled Slope and Y-Intercept. By the end of this video, you'll have a better understanding of the components of a linear function. You'll be able to find the slope of the line along with its starting point, or as it's come to be understood to be named, the Y-intercept. Please leave a like if you find this video to be helpful. Give your classmates a heads up too. It'll more than likely help them, and certainly it'll help this channel be seen by more students. If you would like me to cover any of these topics in greater detail, please leave a comment in the comment section below. I read them and do my best to address each as time permits. Please subscribe to my channel and ring the bell icon to be notified every time I release a new video. Thank you. Let's graph some equations. Objective 1, finding the slope of a line. So let's come up with a mind picture that'll help us remember the concepts we're going to talk about here. I'll come up with a little story to go along with it. So imagine you're on a roller coaster and you're cruising along. The slope is like the steepness of the ride. How fast you're going up and how fast you're going down. If it's a steep hill, the slope is high, and if it's a gentle slope, the slope is low. So now let's talk about the y-intercept. The picture a roller coaster starting at the ground. At that point is where it begins. That we're going to call the y-intercept. It's where the line touches the y-axis. It's like saying, hey, this is where we kick off the ride. So when you're dealing with a line in math, it's often written as y equals mx plus b. The m stands for and is the slope. How steep or how gentle is the line going up or down? The b is the y-intercept. Where does it start? So let's break it down as an example. If you have a line like y equals 2x plus 3, the slope m is 2. And the intercept, the y-intercept, b is a 3. That means that for every step you go to the right, you go up 2 steps. It's positive, up 2. If it were a negative slope, you'd go down 2 steps. And the line starts at the point 0, 3. 0 is on the x-axis, and right above that 0, you count up to 3, and there's 3. That's where the dot would start the line right there. The line can go both ways from there, generally, but that's where it starts. We think of it as starting there, and you can do your counting up and down to measure off the slope from that point. So next time you see a line, think of a roller coaster ride with the slope determining the thrill of the journey and the y-intercept making clear where the adventure begins. Okay, thank you. Example 1, using rise and run to find the slope. So in the past we've talked about what the slope was m. Well, that m is a number, and that number can be 1, 2, 3. It could be 3 halves. It could be 2/10. Whatever the number is, it's allowed to be that number, and that's going to determine your slope. Well, we're going to look here at a graph. They want us in this example here to find the slope of these lines. There's 2 lines for A and B, and they're giving us an equation that slope equals the vertical change divided by the horizontal change, or the rise, the vertical change, divided by the run. You'll often hear us say the rise over run, rise over run. Well, rise is how high it goes, and run is how far it's going in horizontally. Well, that'd be the x-axis. So if we look at the first example here in problem A, we're going to have to say, well, what is the slope of this line? Well, we see here at the start of the line, and when I say start of the line, it could be 0 on the x-axis, but we're just a random line out in space without a coordinate system. We're just looking at slope. It starts here at point 2, right here at point 2. Excuse me. And it goes up, the rise, looking at our equation up here, the vertical change is red, the rise. So the rise is how many? 1, 2. So if we're going to write out our equation up here, we would say what? We would say slope, right here, slope. Slope, I'm going to say S for slope. Slope equals the vertical change, or the rise, and the vertical change in this case is 2 units up. So it's going to be 2 divided by, and what's the horizontal change? The run. Well, the horizontal change is starting at this point right here, 1, 2, 3, 4. So it's going to be 2 over 4. Okay, and if you're going to write an equation, then it would be 2 over 4 m plus some b, and the b, if this was the x-axis, and this was 0 down here, it would be right here, okay? So, well, right now we don't have that. We could determine it, but we don't need it. So anyways, I'm just saying, and this, of course, is 1/2. So 2/4 equals 1/2, okay? And that means that what that's telling us, that the slope is 1/2. That means that for every two counts we go in the horizontal axis, we go up 1. Go over 2, go up 1. And that's where you get the rise is 1 over 2. You could start it this way too. You could say go up 1, it's in the middle, and over 2. So that's the same kind of a concept. So let's look at the next one, B. So in B, we're going to look here. We're going to start at this point here, okay? And we want the slope. So it's the vertical. Well, it's going to be easier to do the horizontal first. So I'm going to say that same thing. S is equal to, I'm going to put the line right here. We can do the horizontal, the x-axis stuff, the horizontal change first. And that is 1, 2, 3, 4. So we can put a 4 on the bottom. Okay, so what is the rise or fall? Because it's also the fall. It's a negative number. It's falling. It's 1, 2, 3, 4, 5, 6. Okay, so it's 6 over 4, or 3 over 2, which is, so you can go over here, go down 3 and go 2. As you see here, go 2. You're going to go from the 3. Well, I'm not going to draw there. Anyways, you can come up with your 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6. So 1, 2, 3 over 2 to the 3. It's the same thing. So you're going to fall 3 and go over 2. But we weren't, so, and anyways, this is a negative. We're going negative. Okay? So that's an idea of how to look at the slope. So negative numbers going down, positive numbers going up in the y-axis. Negative x, negative, you can have a negative x too. If you're going the other way, it's a negative x. So that's, okay? Okay, and check your understanding for example 1. This is the same thing we just did in the previous slide, except now you're looking at it with a coordinate system instead of a checkered pattern. This one literally shows a line starting somewhere on the coordinate system. Again, the equation we're using is slope over here equals vertical change divided by the horizontal change, and they call that the rise over the run. Vertical change is rise is how high is it going up or down, rise, and run is how far it's moving to the right. Okay, so let's start it off. We can say that we want to measure a starting point and an ending point. So we're going to look at right here. We're going to look at the rise in this case is going down. So since the line is going this direction down, it's negative. So when it's going up, it's positive. Going down, it's negative. So we're going to start off with negative. We're going to go down. We're at 2, and we're going to go, we see the line here. It touches the x-axis right here at 4. So we're going to go down 2 and run. So we're going to go, our rise will be down negative 2, and we'll run 4. And when we calculate that out, it's going to be minus 1/2. That's the slope of this line. For every 1 we go to the right, we're going to go down. For every 2 we go to the right, we're going to go down 1. Negative 1/2. Down in this case. Okay. And also, since we do have a coordinate system here, we could actually write out the equation of this line. And the equation of this line is y is equal to, well, we'll say mx plus b. And so y is equal to m, which we know is this. The m is the slope. The slope is minus 1/2 x, here's the x, plus b. And b is what? Well, the b is the y-intercept. We determined that the y-intercept is where the x-axis right here is 0. And where when you get to that point, you'll see exactly where the line crosses the y-axis, and it happens to be at point 2, at 2 at this case. So the intercept is 2. So the equation of this line is y is equal to minus 1/2 x plus 2. So example 2, using coordinates to find the slope. So the last time we looked at the graph and the line and kind of determined what the slope was by looking at points being crossed by the line and solving the equation that way. There's also another way to solve the slope, and that's mathematically. And we do that by saying here that, again, the slope is equal to, this time it's the difference in the y-coordinate values divided by the difference in the x-coordinate values. Okay, so how do you find the difference? Well, they're giving us 2 points here. They're giving us a point C, which is minus 2, 6, which is the x-axis. Minus 2, not the x-axis. Minus 2 is the x value, and 6 is the y value. And over here, the point D, the 4 is the x value, and 3 is the y value. So in order to do the equation, they're showing you here that you take, in this case, they're going to take D, and they're going to say take the y, because we're doing y coordinates on the top. So you say y, which is 3, right here, 3, minus the y from the one you're subtracting from it. So now we're talking about the y, and this, you started with D, the y value is 3. With C, the y value is 6. So it's 3 minus 6. 3, because you're subtracting them. To find the difference, you have to subtract. So we're going to take 3, and we're going to subtract 6. The number's positive, so we're subtracting 6. So it's 3 minus 6. Divided by, now we're going to get the x value. Here, the x coordinates right here. So now we're going to take 4, which is the x value in this term, in the D spot. 4, right here, 4. And we're going to subtract, but what are we subtracting? We're going to subtract a negative 2. So we put it in parentheses here so you don't forget it. 4 minus a negative 2. And then when you do the math on this, you're going to get 3 minus 6 is minus 3. 3 minus 6 minus 3. And 4 minus a minus 2. Well, minus a minus is plus. So it's 4 plus 2 is 6. So when you simplify this, you're going to end up with 3 over 6 is 1/2. It's negative, so it's negative 1/2 is the slope of this example. Okay, example 2, we're going to check our understanding. Find the slope of the line through each pair of points. Let's start with A here. So going back to what we just learned, that to find the slope, you take the ending point and you subtract the starting point. And in the numerator of this, we're going to have a fraction with a numerator and a denominator. The numerator has the y values and the denominator has the x values. So let's go ahead and write that. We're going to have here that we're going to start and write m for the slope is equal to the ending value, and we're going to allow q be the ending value. So it's minus 7, and then minus a minus 1, minus a minus 1 over 0, the ending x value, minus 8. And if we math this out, we're going to have minus 7 minus a minus 1 is plus 1 is equal to minus 6 over minus 8. And that equals 3/4, because a negative divided by a negative is a positive. So our slope m is equal to 3/4. This one here, our end point is going to be the r, our start point is going to be the s point here. So m is equal to, you take the y value from the end point, which is 9, and you subtract the y value from the starting point, and that's 3. And we put that all over the x value from the ending point, which is minus 10, minus a minus 4. A minus 4. Okay? And what does that equal to? 9 minus 3 is 6. And minus 10 plus 4, because minus a minus is plus, minus 10 plus 4 is minus 6. The answer is minus 1. So m, the slope, is equal to -1. Okay, example 3, finding the slope for special cases. And these are special cases for sure. So let's look at the first one here in A. It shows this little graph here, this graph paper, and a line, a horizontal line running through the number 2. Okay, right here it goes through 2, so that's kind of, we know at what height this is. But what it wants us to do is find the slope. Well, let's go to our slope formula and use the mathematical version of it. And before we do that, I'm going to name off a couple points. So I'm going to say this is the ending point, E, down here, the ending point. And this is, in the x direction, it's 2. So it's going to be 2, comma, and in the y, it's 2. So it's 2, comma, 2. I'll put the parentheses around here. And the starting point, S, way down here, I'm going to call that minus 3 for the x value, minus 3, comma, and 2. It's got a 2 again. Okay, so now we're going to use the formula to figure out what the slope of this line is. Okay, so we're going to take and say that, I'll say m, as I did before, is equal to the ending value, y on top, remember, x on the bottom, it's rise over run. The x is the run, y is the rise. So it's going to be, and it's the end minus the start. Okay, so end is 2 for the y. This is the y value right here. So we have 2 minus 2. That's this 2 minus this 2. And that's over 2 minus 3. Minus 3. And then if we work out the mathematics, this is 2 minus 2 is 0. And on the bottom, it's 2 plus 3. Minus a minus 3 is a plus 3. So it's 2 plus 3 is 5. Okay, so what is the slope? Well, as we see from this fraction, that any fraction with 0 in the numerator, doesn't matter what's in the denominator, is 0. So the slope of this line is 0. And as you continue on in mathematics, if you go on into calculus or some of those, you're going to find out that this is pretty important. You use this 0 slope quite often in your problems. Okay, so now let's go to B. It's a different one. Now we've got a vertical line. What's the slope of this vertical line? Well, doing the same thing. We're going to start way down here on the bottom. S is minus 4 for the y, but it's minus 2 for the x. So it's minus 2, minus 2, minus 4. Okay, that's where we're starting. Minus 2, here's minus 4, and minus 2 right here. Okay, so up here at the top, we have the end point. And that's going to be what? End is the y value is 3, but the x value is minus 2. So again, this is going to be minus 2, the x value, plus, or not plus, just 3. It is a plus 3, a positive 3. Okay, so from here, the end point minus the start point, we can find the slope. So again, I'm going to use m as that slope. I like that now. So m is equal to the y value, the ending y value, 3 is in the numerator, 3 minus the ending, or the starting y value, which is minus a minus 4, and over, now we're going to do the x's, because it's rise over run. So the x's say minus 2, minus, what is this? Minus 2. So minus 2 minus a minus 2 is 3 plus 4. 3 minus a minus 4 is equal to 3 plus 4 is 7. All over minus 2 minus a minus 2, which is a plus 2. Minus 2 plus 2 is equal to 0. And what is the answer to this one? Well, we know now, and we've learned from the past, that you cannot divide by 0. And that's not defined. I'll say ND for not defined. So there is no slope here. You cannot have a slope in a vertical line. And 0 is the slope of a horizontal line. Okay? Okay, checking your understanding for example 3. This is just 2 more problems of exactly the same thing we just did. And we're going to just do it again. Get familiar with it. So we're going to say that the ending point on A is this one right here, and the starting point is down here at the bottom. So we're going to go over here and write the equation. M equals the ending point y value, which is 5 minus, I want to say that, minus 3. Minus, parenthesis, a minus 3. Here's the minus 3 down here. And that's over the x values. The ending x value is 5 minus 5. And that equals 5 minus a minus 3 is plus 3 is 8. 8 over 5 minus 5 is 0. This is undefined as before. Remember, the vertical line is undefined. So it works no matter what. Let's do the B. We're going to find out that this is a slope of 0, right? Let's do it. M equals. So I'm going to say, which one are we going to do? We're going to say the ending, the end point is here on this side, on the right, and the start point is on the left. So we're going to end where y value is minus 2 minus, and here's the start value, minus 2. Minus a minus 2. I had to put the parentheses around there. Divided by, now we're going to do the x values. Minus 2, minus 2, minus, and on this side, on the x, at the start point is minus 6. Parentheses, minus 6. And that equals minus 2 plus 2, minus a minus 2 is plus, minus 2 plus 2 is 0, over minus 2 plus 6 is 4. The answer is the slope is 0. Same as we did the slide before. Okay, another refresher for us. Objective 2, using the slope to graph linear functions. Well, this should be familiar because we've done this. We're just doing this to sink it in better. So here we've graphed, here on this side over here, we've graphed y equals minus 1/2 x plus 3. Well, the line is going down this way, going down. So that means it's negative. So what you have to see is this negative right here. That's what says the graph is going down, that the line is going down. The 1/2 says that the movement in y is -1, and the movement in x is 2. So if we're here, and these are every 2 tick marks is 1. So this is starting down here at right there is x and y equals 0. So this is the 1, and this is the 2, and this is the 3 here. So we're going to start here at 3, x0, okay, at 0, 3. We're going to start right here, and we're going to count down negative. Down 1 from here to here, and over 2. 1, 2. So you look at this. There's the slope. It goes down 1 over 2. Do the same thing. Down 1. down to here, over 2. Okay, same kind of slope going here, right down. I missed it a little too tight, but I think you see the picture. And then from here, it'll do the same thing. It'll go down here, 1, and over here, 2. We're going to get, so that's the step. That's our slope. And the plus 3 is the y-intercept. Well, the y-intercept is always found by going to the x position on the x-graph, the 0 position on the x-graph, and looking for whatever the number is. If it's here, it says plus 3, you go up 3. 1, 2, 3. Here's the y-intercept. Okay? So the slope here is, it says the number could be minus 2 over, it is minus 2 over 4, or minus 3 over 6, however you want to do it, or minus 1/2. And that's what we showed you, 1 over 2. So the y-intercept of the line is a point where the line crosses the y-axis. We call that the starting point too, because from here you can do line in positive slope, negative slope. They can all, because they all go through this point. There's a point somewhere way out here in the distance, somewhere way out in the distance, way out here, where this line goes through a point that could solve this be a solution to the equation. But right now we only care about these up here around the y because they're easy to see and easy to calculate. Okay, so here it is again. Y equals minus 1/2 plus 3. The slope is minus 1/2. The y-intercept is the plus 3. It says key concept, slope-intercept form. You're going to hear that a lot, and time's going to come up where you're going to be changing from one type of line format to another format, but this one you're going to be going into very often. Okay, so this y is equal to mx plus b. Just remember that. Commit it to memory. Y equals mx plus b. And m is the slope. B is the y-intercept. And you can use the slope-intercept form. They call it the slope-intercept form of the line. Slope-intercept. There's another one called point slope. So this is slope-intercept. And the slope-intercept form of the line is how you can graph it, because you right away you know where it goes through the y-axis. Boom, you put your point right there on 3. And then you start counting according to your slope. Go down or up over how many? 1, 2, 3. Okay? Okay, example 4, a real-world problem. So there's a warehouse here and a door that's above the street. And there's a ramp that goes out from the door out to the street. And it's so many feet out from the street. Okay, to tell you... get from the door, the side of the building where the door is, out to the street. So it says a ramp slopes from a warehouse door down to the street. The function y equals minus 1/3, right here's the equation, minus 1/3 plus 2 is the equation of this line. Okay, and it says models the ramp where x is the horizontal distance in feet from the bottom of the door outward toward the street, and y is the height in feet above the street. Graph the equation, we've already graphed it, by the way, and explain how to calculate the slope. How, from this graph, by them giving us the numbers 2 feet and out to the street, right? They want us, how do we come up with a calculation for the equation? So we're going to look at this. First of all, we're going to say plus 2. We know that is the y-intercept, or the starting location. And we've already said that here's the starting location where x is 0. We said that in the previous slide. Where x is 0, go up from there and y, and where the line crosses y is the starting point. Here's the plus 2, the same plus 2 that's in the equation. And then we're going to go down in slope. It's a negative slope, negative 1/3. So that means that the slope is going down in the negative. Not positive, going up, going down. And the other thing you need to know is that there's these tick marks here are a half going in y, and they're 2 in x. So they're not in proportion to each other. But we can live with it. We understand that this is more scrunched up down here than going up in the y. Okay? So we're going to start here. We're going to go down 1/3. We're going to go down 1. And we go down 1, we're going to go 3. 1 in the x, 2 in the x, 3 in the x. So there's down 1 over 3 right here. Down 1 over 3. Now we'll do it again. We'll go down 1 and we'll go over 3. So we went from 2 to 6. When you can use this now, we can say that the slope m is equal to minus 2 over 6. And that equals minus 1/3. So you see that in the picture. And we know that it's plus 2 is this intercept. So we can say just what they say right here. We can say that y is equal to, we could write it this way, 2/6 x plus 2. But of course we'd reduce the fraction. It would not be proper to leave the fraction like this. So then it ends up is 1/3 x plus 2. The same as the equation up here. So okay, here's our last two problems. And for real world problems, the real world because we're drawing them up here. Graph each equation. So they want us to graph these equations just by looking at the function y equals whatever mx plus b, and we want to draw it on the screen here. And we've got the little coordinate systems, and we can set the numbers to anything we want. We'll pick easy ones, hopefully. So it says graph each equation. So what's the first thing to do to graph the equation? We're going to do A. The first thing, y equals 2x minus 3, is we're going to graph the starting point, the y-intercept. And the y-intercept says it's starting where x is 0, right down here, x is 0 and y is 0, by the way. We're going to go down minus 3. And I'm going to do every 2. 1, 2, 3. So right here at minus 3 on the y, right there, is what we call is 0, comma, minus 3. Okay? That's that point. So now we want to, from now all we have, we don't know where the line goes, but we have a slope. And that slope is positive. So that means that the slope is going to go up in this direction. And it's telling us that the fraction here is 2 over 1, because it's over 1. Of course, the number here, all fractions are like this, with an integer in the denominator, and the numerator rather, are over 1. Okay? So 2. So what does that mean? It means we're going to go up 2. Every step 1 we go over. So I'm going to go positive on the 1. I'm going to go at x. Okay, here's 1, 2, doing 2 at each one. So it says I'm going to go over 1 and up 2. Here's 1 and here's 2. So that's going to be right about here. And then I'm going to do it again. Over 1 and up 2. Where's this one? Now we're going to go up 1, 2. So that one's going to go right up about here. Okay? And if you look at it, we had a dot here to start. There's a dot out here. And this one here is 2, 4. 2, comma, 4. Those are our 2 points. So the slope of this line is 2. We know it's 2 because we calculated it that way. And if you draw the line through it, it's hard to draw this line. But there you go. As close as I'm going to get it. So there's the line. Upward sloping. Okay. Next graph. B. Y equals minus x plus 4. Well, minus x we know is what? Minus x is equal to minus 1 over 1. Because this x. Because there's always a default 1 when there's no coefficient other than a blank or a negative sign like this. It means that the coefficient is 1, 1x. And a negative means negative 1 over 1. Because you need a fraction here to get the y value, and the x value. So now we know that we're going to go over 1, up 1, over 1, up 1. But it's negative. So actually, it's negative. So it's going to be, I think I put the negative right here. This was the negative. So we're going to go down 1 over 1, down 1 over 1. Okay? So, and it's at plus 4 that it starts. So we're going to go back to the 0 point. X and Y are both 0. And we're going to go 2 for each number. We're going to skip every other one. down here. We're never going to get down this far, I don't think. We're going to go out here. 1, 2, 3, 4. We could do negatives. -1, -2, -3, -4. And now I'll just put -2 here. I'll put 2 out here so everybody knows. Here's 2. And down here's a 2. Okay, so now we know where and this is a -2. Okay, so it says start at +4. 1, 2, 3, 4. Here's where we're starting. X is 0, Y is +4. And then it says going in the negative direction, sloping down. We're going to go down 1 over 1, down 1 over 1. So that's just simple. We're going to go down 1 over 1 right here. Down 1 over 1 right here. Down 1 over 1 right here. And if you draw a line through them, if I can, here's our downward sloping line. And we've graphed that equation now. Okay? And I'll put the points in here. So this was 0, 0, 4. And this one ends up being, we'll go down to, we can pick, this one here is 1, 3, or 0, 4. Okay, let's do it that way. We'll do 0, oh, not 0, sorry. I'm going to erase that. This one here is 4, the x value, 0, the y value. There we are. Sorry for that little mishap.